Welcome back, everybody. This is the fourth OpenCV video tutorial, and today we'll be covering OpenCV and Qt. For those not familiar with Qt, officially Qt is pronounced Qt, but honestly I prefer to call it Qt, so I'm going to stick to that. Qt is free for non-commercial use and was originally developed by a company Trolltech in Norway, which was subsequently bought out by Nokia in 2008. And Qt is, I hate to say, a direct competitor to Microsoft Visual Studio, but honestly, it really is a direct competitor to Microsoft Visual Studio. These are the two big environments out there today, is Visual Studio and Qt. Qt is cross-platform, so it'll run on cell phones, Windows, Mac, Linux, etc. And Qt produces true compiled executables, and it is ANSI C++. Qt provides a really easy-to-use GUI for developing forms. But at the same time, Qt also allows direct access to memory or hardware when needed, and because it's regular ANSI C++, you can call other programs written in C or C++ very easily without needing to use wrapper classes or functions or anything along those lines. In my experience so far using Qt, the more I use it, really the more I like it. Qt seems to be really the perfect balance of making development quick and easy, but at the same time, if you're looking to do direct access to memory, hardware, other programs, etc., it doesn't get in your way or prevent you from doing that. And if you're interested in learning more about Qt, if you do a YouTube search on Void Realms, you'll find a channel with over 100 tutorials on Qt. And this channel is really great for learning Qt if you're new to it. Void Realms. Each of these videos they start, this person here starts with the installation of Qt for somebody that's never worked with Qt before and works all the way up to advanced topics like multi-threading, full-size projects and so on. And each of the videos are, they're typically about 10 minutes in length and kind of one subject at a time, sort of presentation, so it's real easy to pick up on one thing and then go to the next and go to the next. Great way to learn Qt. If you're interested in Qt further, I definitely recommend checking out this channel. But for today, let's get started by downloading Qt from the Trolltech site, or Nokia site, I should say. And of course there's different versions here, the embedded development one and so on, but we're going to stick to the regular version here, Qt 474 and Qt Creator, that's the environment. And we'll choose download, and then Windows offline installer is better. That way you can reinstall it later if need be. And we'll go ahead and jump forward in the video while that's downloading. It's a pretty long download. Alrighty, so now we have Qt installed and started up. Let's go ahead and do File, New Project. So here we're going to choose Qt Widget Project and Qt GUI Application. Choose, and for the name, we'll save it to C Qt Programs. Use as default project location. And then for the name, let's call it Qt Tracker 3, and then next. Now this next screen here can get a little confusing depending on which compilers you have installed. Here we're going to use the compile from the previous video from source. You want to make sure whichever compile from source you do, you have the with Qt option of OpenCV checked. And you'll notice that Qt auto-detects your compilers. Now, on this particular computer, I have Microsoft Visual Studio 2008 and 2010 installed, and you see it's detected both. So we're going to uncheck, choose Create Build Configurations manually. These will give you multiple builds, which we really don't need. We can just stick to the one debug build to keep things simple. And if you have shadow building checked, go ahead and uncheck that. Otherwise, you'll get the multiple builds, which, again, confuses things for what we need to do at this point. So we're going to uncheck the Visual C++ 2008 or anything other than 2010 if you have other compilers on your computer that it detects. And then to be consistent with the prior videos, we're going to stick with the debug version, so let's uncheck the release version. So we should only have one checked at this point, desktop, uncheck shadow building, and create build configurations manually. And then we can go next. And QMain window is typically what you would use for a Qt project if you needed a window with a toolbar, lots of fancy controls, but we're going to have a relatively basic project here. We're really just going to show two images on our form, and then we're going to have a text box and then a button. So in that case, it's better to go with the dialog control as our base class here. That'll make it a little bit more simple. And make sure generate form is checked, all the other defaults are good, and we don't need any version control or project management. Go ahead and choose Finish. And here's our project. So the first thing that we're going to need to do is just how we did with Visual Studio, is we need to make sure our Qt project knows where our OpenCV install is located, and the way that we do that in Qt is with the project file here that ends in .pro. So let's take a look at our install again. Of course, we need to add the bin variable to the path. Go ahead and reference the previous video if you haven't had a chance to do that yet. Just as a matter of review, if we go to C OpenCV 2.3.1 My Build, bin, and debug, this is the location rather that you want to add to your path variable. The other two locations that are important to keep in mind are, if we go to C OpenCV 231 OpenCV, bin, and include, we're going to need to, here we see OpenCV and OpenCV2, so if we go into OpenCV2 we see the header files. So we're going to need to tell the Qt project about this directory here, and then also the library directory, which is going to be C OpenCV 231 My Build, Lib, and Debug. So we're going to need to name these files here in the Qt project file so the Qt project knows about these also. Okay, so now back to our project file. So we're going to start with the include path. And the syntax for these project files is going to look a little odd at first if you're not used to it, but after you kind of get used to it a little bit, it'll be pretty straightforward. So here we're going to do include path incremented by plus equals C:\\\, OpenCV -2.3.1 /OpenCV /build /include. And then the next line that we're going to put in is the library line. So this is going to be libs plus equals dash uppercase LC :/OpenCV -2.3.1 my build /lib /debug, and then a space and a single backslash. The single backslash is the line continuation character, which is the reason that for backslash in the file names we have to include a double backslash. So then we'll go down one line, tab over, and then we're going to include in this area here all the related file names in the OpenCV 231 My Build Lib Debug directory, but we're not going to include the extensions. OpenCV won't work if you include the extensions. So instead of that, here's what we're going to do. We're going to do -L OpenCV. So for example, for Calibrate 3D, we'll type CALIB 3D 231D space / line continuation character. Now you'll notice there isn't actually a file named OpenCV Calib 3D 231D in this directory. There's one with the same name and then .exp and then .lib, but we don't include those file extensions. So now the next thing we're going to do is the contrib 231D, and again we won't include the lib or the exp. So the next line is going to be -L OpenCV _contrib 231D space line continuation character. And at this point, since there's a lot of file names to type in, I'm going to fast forward the video while I type in the rest of them. Alrighty, so now we're finished with our project file. So a couple things to note on the last line. Of course, you don't want to include the backslash because there is no line continuation for the last line. And also, this might seem like a lot of typing, but the thing is you can simply copy and paste this highlighted area here into your next project and the one after that and so on, as long as you include them all in the first one. So you really only have to type this out once and then you're all set. But before we actually code anything, let's go ahead and take a look at our form and the nice friendly user interface that Qt provides for us. So up here in Tools, we have all the options you would expect. You can edit your C++ spacing and so on. You know, text editor, you can choose your colors. One thing I would encourage you to take a look at is the designer. And then you can choose forms, and I have my grid set to X and Y both to be 4 pixels and snap to grid and visible. To me, I think that makes it a little bit easier to align the components on the form. Also, something else you should know about Qt is, especially part of the operating system independence, is there's these controls at the top that attempt to assist you in placing components on your form without making things dependent on specific pixel locations, but it gets a little bit more involved to get into these, and just for a quick simple example today, we'll just place them on the form based on pixel locations. So we're only going to need 4 controls on our form today, or actually in Qt they're officially called widgets, and they're in this box over here. We're going to use 2 labels. That's what we're going to display our image on. So you simply left click and drag. And then we're going to have a button to pause the camera. And then we're going to have a text box to display the X and Y location and the radius, just how the command line did in the previous programs for us. So you'll notice in the display widgets there's a text browser, but that's a rich text browser. You'll notice the A is italicized and in green. And there's also, under input widgets, there's a text edit with rich text. Again, you'll notice the green italicized A, but instead of those, we're simply going to choose the plain text edit input widget, and since there isn't one in the display widgets with the plain text, we'll simply choose the input widget for plain text and then set the input property to not be allowed. So let's go ahead and resize our form a little bit here. To be consistent with the previous videos, we'll go ahead and make the labels 640 by 480 and keep our camera setting at that. Now also, the labels have this property, you can't necessarily see them on the form without the grid showing through which makes them difficult to place until you choose this property down here, autofill background. And there we go, that's going to make it a lot easier to place the labels. And then next we're going to choose the size of them. So width will be 640, height will be 480. And let's place them, let's do 1 grid row from padding from the sides. There we go. And we can delete the text. There's a text property where you can simply right click on the label and just change text and delete it. And then we can resize our text widget. First, let's resize our form to our labels. Jumped off the screen there on me. Alright, that's good. And then we can resize our text widget also. And now we can resize our form some more. And what this button is going to do is, and this is really more to illustrate some of the functionality you can do with OpenCV within Qt, is it's going to pause and then resume. So by default, we're going to have the text set to pause. And let's go ahead and edit the font so we don't have to squint. And let's use 12. That'll be big enough. And it's going to be desirable in our text control to have the text display in columns that match. So we'll choose a fixed width font for that. So let's choose 10 so we don't have to squint. And then good old Courier New is always a good choice. And now all that's left is to name it. So to be consistent with the previous project, let's call the first label LBL Original. That'll be the original image. And then we'll call the second one LBL Processed. And then we'll call the button btn. We'll call this pause or resume. And the text will change as the button is pressed. And then we'll call our text widget txt xy radius. And let's make sure we set the read-only property to true. Here we go, read-only. So that way the user will be able to highlight anything in here if they wanted to copy and paste the ball locations out to a text file. Say they could do that, but they won't be able to actually type in there, which is ideal. Alrighty, at this point, let's go ahead and save it. And now we're ready to add an event, and we're only going to need to add one here. That's for the pause button. So in Visual Studio, if you double-click a button, it starts writing the method for you. In this case, if you right-click on it and go to slot, Qt's wording for, instead of calling things events, they call them signals and slots. We'll get into that a little bit more as we go. So what we're going to do is, for a button, you almost always choose the clicked event, but there are others here if you need them. So we'll choose clicked, and you see it starts to write the code for us. Alrighty, so now our form is done, and the project file is done, so now we can edit the dialog.h file. So we have a private slot, and then we're also going to add a public slot. So we'll have a section public slots. So then we're going to add CV video capture. Many of these are going to be very similar to the second tutorial. I would definitely suggest go ahead and reference that, as need be. So we're going to declare a video capture cap webcam, then CV mat original, and CV mat processed. And then we're going to have, here's going to be a little different from the second tutorial. We're going to have these OpenCV matrix images that we're going to work with manipulating the images in terms of finding the ball and so on in OpenCV. But to display on the form, we're going to have to convert those to a Q image. So we'll declare rather Q image original and Q image, and we'll abbreviate Q image QIMG processed. Then we're going to declare the circles vector and iterator for the circles vector, just the same as in the second tutorial. And now the iterator. And lastly, we're going to have to declare a timer. And the reason for this will be apparent as we continue on in the program. But here's the idea. In a graphical application, you can't have a loop that says something like while one or while true. Because if that loop took the processor all the time, your form wouldn't be able to respond to button presses, form resizings, moving the form around the screen and having to repaint it, and so on. So what we're going to have to do is declare a timer control, or class rather, and then we'll use that and call that every so often to process a frame, and then the program, when it's not doing that, will be able to do the other activities it has to do to manage the form, the graphical use of the program, and so on, and then it can also bounce control back and forth to the operating system without being locked up. We're only going to need one timer control to achieve that. And then we're going to have a slot for the timer control, and in the next file we'll see how we're going to link the timer and the slot, but for now we'll write the slot. So that's going to be void process frame and update GUI. So that's good, and now we're ready to, well, let's take a quick look at main.cpp, although we're not going to need to change anything. It's just 4 lines. We can leave it how it is. So now we're ready to edit dialog.cpp. So first let's work with the constructor here. So we're going to have the webcam object we had earlier open, and 0 will choose the default webcam. If you have more than one webcam attached to your computer, you might need to set this to a different number. Then we're going to check and make sure that the webcam was read successfully, and if it wasn't, then we're going to return from the constructor rather than starting the timer, and we're going to show an error message on the text widget. So here's how we're going to do that. If cap webcam.isOpened is false, so we're going to do if user interface txt xy radius append text, append plain text since it's a plain text widget. So then we'll say error cap webcam not accessed successfully. So that will show in the text widget if, like for example, if the user forgot to plug in their webcam, or if the operating system wasn't detected a webcam was plugged in or anything along those lines. And then we'll return. Once we know we have a webcam connected, we're going to start the timer control. So TMR timer is assigned new queue timer. We can simply say this, since this is a relatively small program, we can keep everything in the same class. And then here's the connect line that actually associates the timer control to the process frame and update GUI function. So we're going to call connect TMR timer, signal in all caps, timeout, then this, and slot, process frame, and update GUI. And then we're going to have to start the timer now that we've associated it to a function. So that's simply timer arrow start. And let's go with 20. Now that's the time in milliseconds for each tick of the timer. So in other words, there's 1,000 milliseconds in a second. So we're asking the program to attempt to run the process frame and update GUI function 50 times a second. Now, of course, it's not going to be able to do that. Even if the webcam could stream at 50 frames per second, if you include the processing time for the image, there's no way it's going to be even close to that. So what happens if you have a timer control call a function more often than it possibly can be done? That's okay. It doesn't hurt anything. The timer control is actually a relatively low priority thread, I guess you could say, or process in the big scheme of things as far as the program is concerned. So what the program's going to do is it's going to do the bare minimum stuff it has to do to keep the form responsive to the user. You know, check for button presses, check for resizing, that sort of thing. But it knows that we're asking it to do at least as much as it possibly can as far as calling this event that's connected to the timer. Therefore, it's going to call that event all that it can. But at the same time, it'll still be able to respond to the form and bounce control back and forth to the operating system without the program locking up. Now, you might be wondering, shouldn't we really use threads here? And the answer is yes, we really should use threads here. That would be the official best way to do it. But rather than get into a long, complicated program about threads, this is a quick and easy, down and dirty way to do it, and it will work. So we're going to go with that. And then that's going to complete the constructor. So we're going to pass on by the destructor. We don't need to do any editing there. And now we're going to go to the, well, actually, let's save the button pause and resume click function for last. Let's write the most important function in the program here, which is process frame and update GUI. So we don't need to declare any more variables at this point. We already did all those in the .h file. So we can simply do cap webcam .read. That'll get the next frame. At original. and then if. Actually, before we continue with the if statement, I just realized I forgot to include up here. Include Qt core. That'll give us some of the Qt functionality we'll need. All right, back to the if statement. So if man original dot empty, if that's true, return. So in other words, if the webcam is operative when the program is started, it's going to get past this if statement here and down here. So from this point on, each frame it won't be able to read. So the program's simply going to jump out of this function before it goes any further. And that's going to prevent the program from hanging up. The form won't necessarily be responsive because it'll keep trying to get into this function 50 times a second, but it'll at least be responsive enough to stop the program without it hanging. So the next block of code, I'm actually going to probably fast forward through this in the video because this is going to be very, very similar to the second tutorial. So go ahead and reference that if you have any questions or concerns about this next section of code. Alright, at this point I'm going to slow it down again because this next line has some specific formatting to the Qt text control we're using here. So we're going to do user interface text XY radius, that's our text control, and then append plain text. So no surprises so far. Here's where it gets a little bit more interesting. Append plain text is set to take a QString. So we're going to use the QString constructor here to make sure that everything that's sent into append plain text is a QString. So we'll do QString, ball position is assigned, ball position x equals rather, to use to assignment statements. Okay, so ball position equals, and then we're going to have to actually show the ball position from the circle iterator, but we'd like to keep the formatting nice and neat. Here's how we're going to do that. We're going to do QString number, and this function takes a number, be it an integer, float, etc., and converts it to a QString. Okay, again, no surprise there. So we're going to get iterator circles here. The 0 element, of course, is the x position. And now we're going to add some additional formatting to that. Whoops, just realized I missed a bracket there. There we go. Okay, so here we're going to call write justified. Then we're going to pass two arguments into that. We're going to pass in a 4, which is the number of characters, and then we're going to pass in a blank character, which is the padding character. Let me explain this a little bit. What we're going to do here is, for example, let's say the x position was 50. We'd prefer to show in the text box a blank space, actually 2 blank spaces, since we did not put an extra blank space between the equal sign and where we started. So we'd prefer to have 2 blank spaces, and then a 5, and then a 0. If the radius was 500, we'd prefer to have, if the x position rather was 500, we would prefer to have 1 blank space and then 500, and so on. So here's what we're doing. We're going to write justify it. So in other words, all the parts of the number where there's actually data is going to shift to the right, and the left from the left is going to be padded with this blank character, and it's always going to be set to 4 spaces. So that's going to give us the formatting that we're looking for. And then we're going to do the same thing for the y position. So it's going to be y equals QString number. And this is going to look pretty much the same as the previous line. When we get to the radius, it's going to be a little different because that can be a floating point number. In fact, these are all floating point numbers, but we can display the x and y position as non-floating point numbers because they're going to be whole numbers because they're pixel values, whereas the radius, we don't have that luxury. But we'll get to that in a moment. So it's just the same as before, right? Justified, 4 total characters always, if necessary, pad from the left with the blank character. Okay, then qstring radius equals qstring number star ITR circles. Element 2, third element, is the radius. Now here we're going to use 3 arguments to the number function rather than the 2 we've been using before. We're going to use IDR circles 2, and then we're going to use f. That's to indicate that it's a floating point. And then we're going to use 3. And the 3 is the number of positions that are going to be displayed after the decimal point. So if you, for example, if you passed in the number 5, we'd like to show that as 2 blank spaces, then a 5, then a decimal point, then 3 zeros. That way the character spacing will always be 7, and therefore from one column to the next, as we look at the text box, it's going to be consistent. So to finish this line then, we're going to need to do right justified again. And that's going to be 7 total characters. And then pad the left side as necessary with blanks. And that's going to give us some nice formatting. So now I'll probably go back to fast forwarding since the 2 circle lines are the same as in the previous video. And that's going to do it for the for loop. Now the only thing we have left at this point is, other than writing the button click event, which we'll get to later, to finish out this function is we're going to have to convert from the OpenCV data types that we're used to working with to the Qt image types to display on the Q labels. And here's how we're going to do that. First we're going to have to convert color. For the original image, remember the processed image is a grayscale image, so we don't have to convert color there. And here's the last argument to convert color. We're going to specify the CV constant CV BGR to RGB. So of course, OpenCV keeps its images in blue, green, red format, whereas Qt works in the more standard red, green, blue format. So this line is necessary to make that change. Otherwise, red, green, and blue would be all inverted. And now we're going to get to the 2 lines to convert the original and processed image from the OpenCV data type to the QImage data type, which we'll need them in to display on the labels on our form. So here's how we're going to do that. We're going to call the QImage constructor QImage original, and then we're going to pass in an unsigned pointer to an unsigned character. For the original image, for the OpenCV image, that is, the matrix image, .data. Then we're going to pass in the OpenCV image .columns. And rows. And then we're going to pass in the step property. And lastly, we're going to use QImage's format. And for color images, it works best to use RGB 888. That should work for all color images. Even if they have less data than that, the conversion will still be handled correctly. So then we're going to call QImage process. Why don't we copy and paste this line since it's exactly the same up until the format part anyhow. So we're going to have to change the format at the end. We'll get to that in a moment. So of course everywhere that original is, we're going to change that to processed. And now for the format for grayscale images, instead of the RGB 888, we're simply going to use format index 8. And that'll work for all grayscale images. Now the last task we have remaining is to update the labels on our form. So user interface label original, set pixmap, qpixmap from image, and here we can pass it in the qt image. And now the same line for the processed image. Save some time, we'll copy and paste. And now the only thing we have left to do is write the button click event. So here's the logic of what we're going to do in the button click event. If the timer is currently running, then we're going to stop the timer and change the button text to resume. And whereas if so we can simply use an else if the timer is, we don't even need the if part, we can simply put an else statement, but logically if the timer is not currently running, then we're going to have to start the timer and change the button text back to pause so the user knows they can press the pause button to pause going forward from there. So here's how that's going to look. If TMR timer is active, equals true, timer stop. And user interface button pause or resume. Set text. And now we'll make the button say resume. Got a bracket there. Okay, else, so this would be the case where the timer is not currently running when we get to this point. So we can call timer start 20 and button pause or resume. Set text, pause. Okay, of course we forgot a semicolon there. That's the reason for that red bar. There we go. And now we're ready to save our program and compile it. And we definitely got some compiler errors here, so I must have made some typos. And there we go. That should be timer. Try that again. And Q timer, looks like I missed a capitalization. There we go. Alright, so we got a clean compile out of our program. Let's go ahead and run it and see what happens. And here's our nice form. So there's the ball being tracked, and you see our nice formatting in the text box has kept these columns here consistent. And if we use the pause button, it Sure enough, I'm still moving the ball at this point, but we don't see it because it's paused. Press resume, and there's the resume. It looks like that's working great. Congratulations! You now know how to configure Qt for use with OpenCV, and also how to write a basic object recognition and tracking program with a graphical Qt frontend and making OpenCV function calls. In the next video, we'll take a look at mGoCV, which allows making OpenCV function calls from within a Visual Studio .NET Windows Forms program. See everybody next time.